Hello and welcome to the teaching demonstration. I am Oyan Banerjee. Today I will teach forces in machining and merchant circle diagram. First, the assumptions for the merchant circle diagram. One, tool tip must be sharp, that is the chip must make contact only with the rake face. Two, cutting edge must be perpendicular to the cutting velocity vector. Three, deformation is 2D, that is the chip flows perpendicular to the cutting edge, there is no side spread. And this means that it follows orthogonal cutting operation only. Fourth, deformation takes place in a very thin zone. Actually, it is a shear zone instead of a shear plane. So here it is considered as a single shear plane theory. But in actual, single shear plane theory is not valid because otherwise the retardation, which is equals to Vc minus V chip by tau would be very low, as V chip is being transitioned from Vc, which is very high, and V chip is very low. So tau would be very small, and then leading to the retardation, which would be infinity, which is an impossibility. So single shear plane theory is not valid. It should be shear zone theory. 5, chips are continuous without BOE. 6, workpiece material is rigid and perfectly plastic. 7, R prime plus R equals to 0. Here is R prime and here is R. R is from the tool side and R prime is from the workpiece side. So R can be resolved into F and N. N is the normal reaction force which gives rise to F, that is the friction force. The angle subtended by the R and the N is eta, or the friction angle. And similarly, R prime can be resolved into Fs and Fn. Fn is the normal reaction force, the normal force to the Fs, that is the shear force, which is perpendicular to the shear plane, parallel to the shear plane. And beta is the shear plane angle. And this R prime can also be further resolved into Fc being along the direction of the cutting velocity vector, and perpendicular to it is the Ft, that is the thrust force. Ft, we can see here, Ft is the resultant of Ff and Fr. Fr is the force in the radial direction and Ff is the force from the feed side or the feed direction. So here are the equations. Now these forces end up on the periphery of a circle as per the theory of Merchant. So here Fs you can see here along the shear plane, Fc in the direction of the cutting velocity vector, Ft perpendicular to it, F is the friction force, N perpendicular to F, then Fn perpendicular to Fs. The angle, this is the shear angle beta, shear plane angle, this is 90 minus eta, this is the friction angle, this is 90 minus eta, this one is the gamma naught, the rake angle, orthogonal rake angle, this one is also orthogonal rake angle, this is the perpendicular to this line, and this one is eta minus gamma naught. How? Suppose this one is x, then this is 90 degree, so 90 degree equals to x plus 90 minus eta plus gamma naught, so x equals to eta minus gamma naught. Now, r cos eta minus gamma naught, this triangle, r cos eta minus gamma naught equals to Fc. R equals to Fc by cos of eta minus gamma naught. Then again, this triangle, r cos beta plus eta minus gamma naught equals to Fs. So r equals to Fs by cos of beta plus eta minus gamma naught. Equating these two, we get Fc equals to Fs into cos of eta minus gamma naught by cos of beta plus eta minus gamma naught. Now, mu. What is mu? Mu is the apparent coefficient of friction, or F by N. So F by N equals to AB by BD. This is F and this is N. So AB can be split into AC plus BC. BD equals to OC. So OC equals to MC minus OM. So this can be written as F equals to FC minus FC sin gamma naught plus FT cos gamma naught, or N equals to FC cos gamma naught minus FT sin gamma naught. So mu equals to FC sin gamma naught plus FT cos gamma naught by FC cos gamma naught minus FT sin gamma naught. So this is the apparent coefficient of friction, not the actual coefficient of friction. And here we need to find out the area of the shear plane. Area of the shear plane, how can we find out? So this one is L1 and this one is B1. So B1 is the width of the chip and A1 is the uncut chip thickness. So how can we find out B1? Suppose this, focusing to this triangle, this is S0 and this one is the principal cutting edge angle. So sin phi. So sin phi equals to T by B1. So B1 equals to T by sin phi. So now what is remaining? L1. A by L1 equals to sin beta. Beta is the shear plane angle. So L1 equals to A1 by sin beta, which leads to AS equals to SO plus into T into 1 by sin beta. Now here, putting the value of AS, Fs equals to tau into AS. Replacing this, we get Fc equals to SO into T into 1 by sin beta into tau S into this expression. So Fc, the entire expression for Fc is this, which is very important as this is associated with the cutting power. Now Fn we can find out from this triangle. Fn can be found out as Fn equals to Fs into tan of beta plus eta minus gamma naught. Further, we can divide it by the shear plane area and incorporate the Bridgman's relation and then substitute it in this expression. After that, we can differentiate the derived expression for the minimum energy principle, and we can get the Merchant's first solution. Thank you.